tak já si to budu posílat. Okay, so I am not sure if the audience have heard about even the underlying XML format, which is XLIFF. Can I have a show of hands? Are people aware of XLIFF? Good, good. Thanks. So I was presenting like 2 years ago on XLIFF 2.1, so some of that knowledge is kind of assumed, and you can refer to it in the proceedings from 2017. But oh yeah, it works. So it is largely about the JSON serialization, but sometimes we need to go back a little bit and explain about the business logic in the domain, of translation and localization, about the logic of BitX and so on. So this is joint work. This is presenting work in progress on OASIS committee called XLIFF OMOS, which is a sister committee, different committee to the XLIFF committee. Obviously, for kind of legal IPR reasons, like the original XLIFF committee is only chartered to work on the XML stuff. So the XLIFF OMOS meaning object model and other serialization. This is chartered to work on the abstract model and any other serializations. So obviously, JSON is kind of popular, so the JLIFF is kind of the first, first obvious target. But we could, there were people experimenting with other stuff like protobufLIFF. There are some prototypes for that, but not seriously pursued. So this is about JLIFF. So Filip, that's me. Phil Ritchie and Robert van Engelen, they are fellow colleagues on the XLIFF OMOS TC. Robert van Engelen, he is the editor of the JLIFF schema, which is a JSON schema. And Phil Ritchie is a member of XLIFF OMOS, and he's author of a open source reference implementation called JLIFF Graph Tools. So the references are in the slides and also in the paper, in the proceedings. So you can experiment with that. So unfortunately, they wanted to come. I told them about unlimited pork and beer in the Strahov monastery, but they were highly motivated but had conflicts. Anyways. It goes blank after every. I should have waited. Okay. So, although this is kind of domain specific, XLIFF, localization, translation, and so on, we are also trying to make observations that will be useful for people who need to port other XML vocabularies. So this is the current XLIFF spec is the XLIFF 2.1 spec, which is backwards compatible with the XLIFF 2.0 spec. And they are backwards compatible by way of sharing all these namespaces. And of those, the most important is the first one. This is the core namespace. And we basically pledged not to change the core namespace for next 10, 20 years, whatever, So the idea is to release, 2.1, 2.2, 2.32, whatever, as long as it, will work. So those are, this is the core namespace, then the translation candidates module namespace, and you may notice that the OASIS namespaces are for historical reasons in the URN form. Glossary module, format style module. The idea is basically that the core is interoperable. Everyone has to support that, process that, and specialized agents make use of of those specialized modules that are isolated in different namespaces. The general idea is, well, if you don't understand the module, if you don't support the module, you just ignore the namespace, right? But the only namespace you cannot ignore is the core. Well, and then there is a thing like ignoring means don't touch it, not delete it. Like you must not delete module-based data. And so basically these namespaces are protected. So this is 2 new namespaces that we introduced in 2.1, and they are namespaces to support the W3C ITS, which is the internationalization tag set. So we are using, for better interoperability with ITS processors, we are using the original W3C namespace. But there was need for some local markup that doesn't exist in the W3C spec. So we made an OASIS-style supplementary namespace for this local markup that doesn't exist in the W3C. So this is basically, if you encounter these namespaces in 2.0, they are extensions. If you encounter them in 2.1, they are modules. So this is the idea of the modular design. Like you can promote extensions to modules from release to release, and also you can demote modules to extensions, because we kind of turned out that this extension change tracking module wasn't the best thought through one, and there wasn't consensus how to fix it, so we basically demoted it to an extension going from 2.0 to 2.1. So it's basically a multimodal vocabulary. Now, we will cover what to do with that when you are going for JSON. But first, I will explain about the LIOM design. So as I said, the OMOS committee is an object model and other serializations. So this means basically we are first describing in abstract ways what is the business logic, what is the object model of the original XML vocabulary. And only then, after we clarified in abstract terms what is the object model, we are trying to port it into different other technologies, one of them JSON. So first, the LIOM design. So the first image will be a UML diagram. The UML diagram is not very well readable. It is also in the proceedings. It is also on the OMOS repository. But I will be explaining it more informally on not so formal. Like the point of the UML is to be the formal stuff, but I have a kind of a presentation. So this is the formal UML stuff. I'm not going to, you couldn't read it and so on. So I am breaking this up into kind of informal diagramming. So this is a localization interchange object model. So and the point is like, the point of XLIFF is being a round trip format. You are supposed to extract your content into the bittex format and do some valid changes to it on your round trip, and then produce the target format in the original format, not in the XLIFF. So basically, there is some strict business logic behind the bittex format. So this is kind of the abstracted top-level structure. This is what we call static structure of the LIOM, the localization interchange object model. So it has top root. This can be different sort of wrappers. But what it represents, is like a LIOM is a collection of content from source files. So it kind of represents structure of the source during the project. So every LIOM has to have at least one file, and each file has at most one skeleton. And then there is a recursive structure of groups, and then there are units, and the units are kind of leaves of the static structure. So the units are kind of self-contained leaves. So you can have, say, each file has to have at least one of group or unit. But the group can be empty. The group can have 0, 1, or more units. But you can have also a totally flat structure of just units. It's basically up to your philosophy of extracting from the source format. Different source formats need different things. But if you want to, basically, there's the option for the recursive structure, so you can pretty much mimic any kind of formats. So this is what we call the transient structure. This is kind of the structure of the unit leaf. So it is kind of not really leaf. It is kind of the payload. The payload comes in the unit. So each unit has kind of a metadata bag, which can contain original data that's needed for knowledge of the original format, and core and data and module-based metadata. Module-based metadata is only like standoff metadata is only allowed in this metadata bag, where it can reference inlines. A unit is kind of a self-contained unit of the content that the translator can tackle, as a unit. So it is kind of self-sufficient it doesn't make kind of references outside of it, or things are not allowed to span outside of it, and so on. So the units consist either of subunits, and these subunits are either segment or ignorable, and each unit has to have at least one segment. And because it's bittext, then each segment and ignorable, they have the same data model. So they have to have exactly one source and at most one target. Obviously, like when you're sending for something for translation, the target is not obligatory because you don't know yet what the target will be, right? But when you are receiving your delivery, target is expected because this is what you send it for. So this is the logic of the bittext. But then, the XLIFF behaves as a proper XML from top to unit, but then it stops behaving like a proper XML because it needs to model, natural language data with all sorts of code and annotations, and also it's supposed to represent all non-well-formed formats. So even it might not be possible even from start, from extraction, to represent it with a well-formed XML structure. So basically, this is why. So unit is self-contained. Well, segment and ignorable are well-formed XML tags, but they can be in the object model of the bittext. They can be spun by code and marker spans that are formed from the XML point of view, empty elements that are in the source or in the target. So the source and target have the same data model. The segment and ignorable have the same data model. So I'll explain here. Again, source and target has the same data model. And this is a sequence of text and those objects. And those objects are starter code, end code, starter marker, end marker, and ph. So obviously, in the XML representation, you can also have their well-formed equivalents, which would be MRK and PC, but we don't have them in the abstract object model because it's an XMLism. So basically, they will be empty from the proper XML point of view, but they are not. They are allowed to form spans. So SC and EC can form spans or be declared as orphaned. It can be necessitated by the logic of the source format within the ancestor unit. So it can span segments. It can overlap with other spans. It's not well formed. So this is codes. So they are allowed to be orphaned. This is annotations. You are in control of your annotations. So you are responsible for having your annotations closed. So they have to form spans within ancestor units. So this is how an XLIFF top-level element looks. There is the core namespace declared, and the version 2.1 is the current version, and required attribute source lang, and the target language attribute is only required if targets are present. And then there is arbitrary group structure. I truncated the payload. This is just to show you how the XLIFF top level looks. If you want extensions or modules, you obviously need to declare other namespaces. So this is, we have hypothetical 2 extensions in this file, so we would declare these 2 extension namespaces. Now in JLIFF, so this is the anonymous top-level JLIFF object. It has a required property JLIFF. The only allowed values are 2.1 and 2.0. Source language, again, obligatory target language only if you have targets. But then JLIFF, well, XLIFF means XML localization interchange file format, and JLIFF means JSON localization interchange fragment format. So the idea is to have a division of labor between the JSON pipelines and the XML pipelines, like JSON being more suitable for exchanging small bits in real time, and XML for exchanging the whole project. Like even, I know, thousands of data topics in one project, things like that. So in the JLIFF, you have an option of what is the top level represented. You don't have this option in XLIFF. So this is basically what one of the use cases is supposed to be, you have an XLIFF in your translation management system. You break out small fragments that are in the JSON format and exchange them in real time in an interoperable way without breaking the object model that is guaranteed by the original XML. So you can represent everything. It is kind of compliant. You can represent files, subfiles, subgroups, subunits. But we think that this one last option, this is the most important scenario. You actually want to exchange in real time. Someone translator working in real time on a workbench and exchange in real time the unit content. So just the subunits. What do I do for modules and extensions? So I do a JSON LD context. So this is a context property, and in JSON LD processors would use this to expand the prefixes UEX1 and UEX2 to create fully qualified names for these extensions. So general design principles. Like, I know that there's a lot of stuff, there's a lot of tools that would make you JSON out of XML and XML out of JSON. But the problem is we need something that has guaranteed round trip, that is guaranteed semantic interoperability, that it behaves the same way after you've modified it in JSON. So this is why we went through the abstract model, the UML. So, and we are trying to strip the object model first of XMLism, SGMLism, to make real native implementations in the other technologies. So things like XML space or escaping illegal characters, we have a CP element for that in XLIFF. This is not needed in JSON. We also dropped the well-formed versions of the spanning codes because you don't need them in other technologies. You have different approach to structure elements, attributes. Well, I will demonstrate. So no mixing character data with markup. So this is a simple source in XLIFF. It says eat placeholder number of eggs for breakfast. It is extremely simplified. There is only minimum attributes used, but this is what it becomes in JLIFF. So this is an well, yeah, sure. So this is anonymous source. This is an anonymous source object, which is a required property source. And basically, as I said, no mixing character data with markup. So basically, you need to have a text key value pair for each character data piece from the XML. And then you need to represent the object as, again, anonymous object of a kind, like kind PH. There is no order in it. So the kind PH can be the last one, But I have the ID one, XLIFF number that's basically telling the translator what kind of placeholder it is. And then I use the well-formed MRK that doesn't have a representation in the object model. There is a mapping defined in XLIFF and in LIOM and in JLIFF. So basically, what JLIFF does for that is forms a pseudo-span from kind SMID2 and kind EMID3 with start ref2. So this is the pseudo-span. This is also what you can do the equivalent in the source XLIFF. But we happen to have here the well-formed one. I'm just showing this mapping. Another thing we're doing in this schema is, obviously, JSON has less rich data structure, so we need for interoperability between the formats things like NC name, NM token. So this is done through restricting strings by patterns or enumerations, whatever. So I don't have much time. Yeah, well, we have some values that would seem Boolean, in XLIFF. They have just yes/no values. But we thought in the object model that they would be Boolean because they are just flux, right? But then we had some discussion, and we decided to actually base them, string-base them in JSON and make them yes/no enumerations because Boolean behaves in a different way than what it intended. Well, if a Boolean fails to come true, you assume false. But if a LIOM or XLIFF attribute yes/no is not specified, the default is yes. So it's basically, in absence of prohibition, there is a permission logic. So yeah, this is the enumerations consideration. And the approach of objects versus properties is actually very philosophically different to the approach of elements versus attributes. And like a lot of JSON people, like they have only contempt for these abominations called attributes. So it is actually so like we have, the structure is philosophically different. Like you don't have like we need to have the plural forms because we need to represent sequences with arrays. So these arrays are wrapped with plural forms. So it is kind of a different word. I already explained that we are using the JSON LD method for fully qualified names to represent extension namespaces, but we are not using it for modules. For modules, we are using an underscore prefix, and the modules are a little bit too much used to have the overhead of the JSON LD processing. So there are some XLIFF, LIOM, and JLIFF resources. All of them are also in the paper, in the proceedings. And that's it. Questions?
So thank you very much, David. We have time for questions. Over there from Felix.
Thanks. You mentioned JSON LD briefly, but could you say a bit more why you choose to use JSON LD and not plain JSON?
Not what?
Not plain JSON.
Oh, plain. Well, we did use pretty much, we used JSON schema for defining the grammar, so to say. But we used JSON LD, we used just this single feature out of JSON LD, and this is the prefixes expansion via the context, because this is we did some quite extensive research. It took us several months to decide what method to use for the namespaces support, and we thought that this has reasonably good support, the JSON LD processing, and it's a reasonably good proxy for the behavior of namespace prefixes in XML.
Okay. Another question? Maybe I will have one question. Maybe I have missed it, but what was the real motivation for creating this JSON representation? Was it like demand from tool vendors, or it was just to be more fashionable?
Well, I think those motivations are not exclusive. It was basically the idea coming from one of the largest participants on the committee, namely Microsoft. There are, I think, Liam made these, references to oiling the machine, to working in the wider organization. Like there are people who are even religiously committed not to use XML, and just to use JSON. But so it's not to be fashionable. It's basically to prevent the JSON community to invent another method that will be semantically different, So that's the basic consideration. And the other is that JSON is really good for real-time exchanges of small bits. So I think that actually the root that represents the one unit actually makes sense, out of it. Like we have for interoperability reasons, we have it. We are capable of expressing any complexity of XLIFF. But I think the real use case is the unit level representation.
Okay, thank you. And thank you again, because I don't, oh, there is a question from Liam, sorry.
Yeah, a fairly quick one though, I think. When people move from XML to JSON for interchange performance, I sometimes ask them if they've considered EXI, which is a very clever way of transmitting a stream of parse events that's compressed, rather like a Saxon, a Sax event, event stream. So you do parsing on the server and then send the parse events. It's a W3C spec. And I chatted to someone who was working with the Internet of Things, which supports both EXI and JSON. And they said they got roughly 3 orders of magnitude more devices they could support with EXI than with JSON.
Interesting.
Okay, so it's worth considering.
So I guess like we can look into it as the other, the almost is really designed to spit out serializations in whatever comes next. That's the idea. Like we are chartered so that we have the abstract model and we can do it in whatever. But the main reason, as I said to Jirka, is so that people don't invent something else in JSON that doesn't make sense and is not interoperable with us.
Yeah, sounds good. You may find that if you use the XI, you can transmit both the JSON and the XML in that format, and it'd be faster.
Good.
Okay.
Thanks.
Okay, so thank you very much again.